Hey guys, today we're going to be talking about the Vernier calipers, and we're going to be talking about the different parts of the Vernier calipers and some quantization in the Vernier calipers. And in a later video we'll talk about how to read and decipher the Vernier calipers, etc. But for this video we'll be talking about the introduction to it basically. So when you're looking at the Vernier calipers, the one right here on the screen in front of you is a general laboratory use Vernier calipers. And so in this Vernier calipers, you'll find three different things that you can put against an object in order to measure something. So we've got these set of jaws, and this stem. So each of these three things has a different need and a different use for it. So when we're looking at these big jaws right here, they are used to measure the yellow dimension. So if you consider this green cylinder as a hollow cylinder or like a beaker, there are three things that I've mentioned here, right? One is the outer diameter, which is in yellow. In the red is the inner diameter, and in the blue is the depth of the cylinder. Talking about this one right here. So so when we're looking at these big jaws, they are used to figure out the outer dimensions, which is the yellow dimension. So this is used in the case of the yellow dimension. When we're talking about these jaws up here, they are used to measure the inner dimension. So in this case would be the inner diameter of the hollow cylinder. And finally, this stem right here is used to measure the depth. The depth or the height in this case of the cylinder. So these three things have different functions which can help us to find different dimensions of an object. Now, when you're trying to measure something, you would normally take this thumb screw right here and screw it over and move this side. This whole unit right here would move that side. And as a result, you would get the reading. So let's decipher the different things that we can use in order to get the reading. I'm just going to erase this thing right here too. And so let's zoom in. So when we're looking at the Vernier calipers, you'll find out that there are two scales. One is right here, and the second one is right here. I think you can see that. That's the second one. That arrow's not that clear, but this is the second one. So this scale right here, that is the main scale. And this is a typical scale or ruler that you'll use at home. So this is the main scale. And it has both centimeters, and the above part is inches. And this scale right here, that is called the Vernier scale. So this is the Vernier scale. And this is where, this is the specialty of this. So by using both the Vernier scale, which is this, and the main scale, you'll find out the reading. Now, you also have the Vernier scale for inches. I'm not sure if it's clear here, but it's right there. And usually we don't use that in the laboratory, but yeah, so we have the Vernier scale and the main scale. So those are the different parts of the Vernier calipers. So right here in front of you on the screen, we have a typical meter scale or centimeter scale. And in this centimeter scale, obviously you see all of those divisions, and each of those divisions, according to the typical scale, is 1 millimeter, right? So that is a typical MSD in a typical Vernier calipers that you find in the laboratory. So 1 MSD is equal to how much? 1 millimeter. Now, in the Vernier calipers that you find in the laboratory, you can see that 9 main scale divisions, which means till here, coincide with 10 Vernier scale divisions. So 10 VSD coincides with 9 MSD. I don't know if that's 10 right there, but I think you understand what I'm trying to say. So from that we've got 9 MSD is equal to 10 VSD. From this we get 9 over 10 MSD, which is equal to how much? 0.9 millimeters is equal to 1 VSD. So far we've got how much 1 MSD is worth and how much 1 VSD is worth. So now when we're talking about these measuring devices, whether it's Vernier calipers or screw gauge or whatever, we need to talk about the least count. And so the least count is the least amount that can be measured by a measuring device. So let's consider an example. If you have a carton, let's just say this is a carton of water or something, and this can hold a capacity of 30 liters, right? And we've got another similar carton that can, carry, let's say, 20 liters of water. So how much is the least amount of water that you can measure accurately using these two? You can try this by yourself, by the way. So the least amount of water that you can measure using these two is 10 liters. So we can do that by filling this carton all the way to 30 liters and then pouring this into this until the 20 liters carton is full. Now, if there's 30 liters filled all the way up here, and you're pouring 20 liters into this so that this is all full, obviously only 10 liters will be left in that. And that's the least amount that you can measure accurately, right? So that's a similar principle that we're going to be using here. So obviously, if we use the same principle, basically what we did before was the bigger measurement minus a smaller measurement, right? So here you could do the same thing. We could do MSD, or 1 MSD, minus 1 VSD is the least count. So that's equal to 1 millimeter minus 0.9 millimeters, which is 0.1 millimeter, or 0.01 centimeters. So this is the least count of the Vernier calipers. And these three are the basic things that you need to know about a Vernier calipers, especially when you're dealing with the regular laboratory version. There are some other questions that can give some twists or whatever, but you can always derive it using the same principle that I've used here. Usually in the question, they would give, how many MSDs coincide with how many VSDs. That sort of information will be given to you, and you can use those information to figure out the least count and all that stuff. But there are some other kinds of exceptions and examples that we can discuss later on. So that's it for this video, part 1, where we're talking about the mathematics involved in the Vernier calipers and also the parts of the Vernier calipers and what exactly each thing does. So that's this video.